So I said I'd record a video for the Chapter 2 review so that if you didn't quite pick up everything in class, you'd have a chance to do that. So I'm just going to read you what I did in class today, maybe say things maybe slightly better, hopefully. Again, if you're feeling a little bit overwhelmed, send me an email and ask me questions. I can answer the questions for you. If I can't get the questions answered in person, you certainly can come visit me in my office. We can get a time and I can sit down with you before the test to make this better. So problem 1 on the review wants me to write a set in roster form. Roster form implies to list all the elements. When I see roster, I think I need to list each element that makes up the set. Usually, when we're listing each element, we use set brackets. So without really getting into the meat of the problem, when I see list in roster form, usually I write the set name with an equal sign, and then to the right of the equal sign I make a set bracket, probably a left and a right set bracket, but I'll hold off on the right until I fill it in. And then inside the set bracket, I'm just going to write the elements of the set. And if the set gets really large, then I might have a ... and that just kind of shows what the elements are without physically writing them down. For this particular problem, the first thing I see is I see even natural numbers. Even natural numbers are numbers like 2, 4, 6, 8, 10. Natural numbers start at 1 and go higher. Evens are multiples of 2. And now I need to be between 10 and 24. If I didn't see the word inclusive, I wouldn't include the 10 and wouldn't include the 24. So the word inclusive with between, you include the endpoints. If I don't have the word inclusive, I'm not including the first and the last number that I see. So I'm looking for even natural numbers starting at 10, including 10, ending at 24. So I'm going to just list all the numbers that are even between 12 and 24. I certainly could have done this with a ... I wouldn't have been wrong if I did 10, 12, 14, ... 24. You don't really have to list every number, just as long as your answer, I can construct the numbers that are in the list. Just in case I do this on the test, if the problem without the word inclusive, so if the problem didn't have the word inclusive, and there's no reason to think I wouldn't do that on the test, without the word inclusive, the answer would have been A equal to, and then it wouldn't have included the 10 and it wouldn't have included the 24. So the word inclusive with between includes the endpoints. The word not inclusive, if this word wasn't in the problem and there was a period right after the 24, then I wouldn't have included the 10 and the 24. So the word between, in general, doesn't include the first and the last number that you see, but when I see the word inclusive, that forces me to put the numbers in the first and the last number. So I can't imagine asking anything too terribly different when I ask problem 1. It's going to be real important to read the problem carefully. When I did the problem in class this morning, I missed this word even, and I started writing 10, 11, 12, 13, 14, and that's wrong because it only wants even numbers. So take the time to read and make sure you pick up all the little words in the problem because they're going to be important. Be cognizant of seeing if the word inclusive is there or not. The next problem, it says find n of A. N of A means the number of elements in the set. And I'm only going to worry about this. This is the real problem. And in the problem 1, N of A asks me how many elements were in the set. I'm just going to write N of A, which means the number of elements of A are, and I'm just going to count. In the set A, there's 1, 2, 3, 4, 5, 6, 7, 8 numbers that I wrote. So I'm going to write N of A equals to 8. For the red set, I'd write N of A equal to 6 for what that's worth. So both 1 and 2, your answers really can't be much different than mine. For 1, you could have did a ... you could have done something like 10, 12, 14, 24. But your answers aren't going to look remarkably different than mine. Your first and your last numbers are going to be the same. You should have set brackets. Number 3, there's a lot of room for variation. There isn't a dead right answer. This problem should say, I guess this is supposed to be set E. This E should have been on this next line. So express this set in roster form. Usually in roster form, I write the set name, and then an equal sign, and then, I guess there isn't. This is just a one answer. I'm sorry. I was trying to think this was a different problem. There's only one good answer for this problem. And listing a set in roster form means to do just like I did in number 1, list all the elements that are in the set. Immediately, when I read this problem, it's given in set builder notation. The first thing I see to the right of that vertical bar, x is an element of n. That means I'm only having natural numbers. I'm not going to have any fractions or decimals. Anytime I have x written between two numbers, then I'm only going to have numbers, between those smallest and biggest numbers. I have to decide whether I need the endpoints or not. And in this particular problem, when I write the elements down, I'm not going to include the 5 because between the 5 and the x, the symbol doesn't have an or equal to. So I need the natural number that's bigger than 5. And I'm going to continue to list until I get up to the 10. I have to decide whether the 10 needs to be in the list or not. Because of the or equal to part of the problem, the 10 needs to be included. So when I'm writing in roster form, I'm writing all the elements of the set. And when x is written between two numbers, it's only ever right to write less than signs. You're never going to have a greater than or equal to. You can have a less than or equal to when you have x written between numbers, and never greater than. The trick for writing in roster form really is just to figure out if you're having the endpoints or not. So x is a natural number. It's bigger than 5, less than or equal to 10. I don't include the 5 because 5 is not allowed to equal 5, so I start off with 6. I do include the 10 because the or equal to part of the 10. So those are moderately friendly problems. Hopefully they go quickly on the test. 4 is the problem where there's multiple answers that are acceptable. I'm asked to write in set builder notation, and I see the set name as A. When I go to write the set in set builder notation starts off with the name of the set, an equal sign, and then a set bracket with a vertical line. To the left of the set bracket, you need to have some letter, and there hardly seems to be a better letter to use than X, so I'm going to write an X to the left of the vertical line. And that by itself could be gotten by just looking at the top line. The 1, 2, 3, 4, 5, 6, 7 I haven't taken into consideration at all yet. I'm going to take those into consideration now, and I need to write something to the right of that vertical line so that I can tell you that I'm dealing with the numbers 1 through 7. Just like problem 3, it started off with x as an element of n. I need to write that in because I'm only dealing with natural numbers, and I have options. I could do it just like I did, just like problem 3 was presented to me, and write x as an element of n. But I don't have to do that. If I don't like the mathematical shorthand, I can use words. And the words that have the same meaning is x is a natural number. And in place of the comma, I can write the word and. So far, these two problems, or these two answers, both say the same thing, that A is the set of all numbers x that are natural numbers, and then I have to write something after the comma so that I understand it's the numbers between 1 and 7. For me, the easiest way, the safest way to do this is to write something like I see in number 3. I need to have an x written between two numbers. If I want to include the endpoints, I put or equal to's. If I don't want to include the endpoints, I don't put or equal to. What I'm going to do is just put an x between a 1 and a 7 with or equal to's and just count both the numbers. So for me, this seems to be the nicest way to write this answer. I can do this anytime I have natural numbers between, including the endpoints. I can just put an X between the numbers with less than or equal to's. Greater thans would be wrong. If you put greater thans, it would mean something different. That would be an acceptable answer. If you wanted to, there's lots of other things I can write that mean the same thing. And a couple things that you can write in place of that. It would be enough just to say X is less than 8 because natural numbers start at 9. If in your answer you wrote X is less than 8 and the natural numbers less than 8 are 1 through 7, in place of this you could write X is less than or equal to 7. Or you can write 1 is less than or equal to X is less than 8. All of those different statements written to the right of the comma or to the right of the word and all mean numbers 1 through 8. I have to have something that tells me I'm not allowing fractions or decimals. That's either X is an element of n with a comma or X is a natural number and written out in words. And then after the word and or after the comma, something to indicate I'm only dealing with the numbers 1 through 7. And the first way that I wrote it I like best, but any of these two ways in red or this way in green, they're all okay. You only have to write one form of the answer. There's not like 3 answers or 4 answers you have to give me, but it just has to be the case that I need to look at your answer and understand that it means the numbers 1 through 7. For problem 5, sets that are equal have exactly the same contents. The order doesn't have to be important, but they have exactly the same elements. Equivalent is they have the same number of elements. So of the problems that are presented to me, in A, the sets A and B are equal sets because they have exactly the same elements. They're equivalent because they both have 3 elements. So for part A, it would be probably proper to say that they're both equivalent and equal. They're equal even though they're not written in the same order. They both have 1, 2, and 3 that makes them equal. They both have 3 elements that makes them equivalent. For part B, this should be a squiggly bracket, but I didn't put it in. Those 2 sets are equivalent. They're not equal because they don't have the same elements, but they have the same number of elements, and that's what it takes to be equivalent. I probably should have added a part C, but I didn't. In doing 2 sets that are neither, I could have like a set D that has the contents A and B, and a set E that has the contents 1, 2, and 3. And this would be an example of sets that are neither equal nor equivalent. So you need to be aware of it's possible that sets are neither. These 2 sets, D and E, which isn't even a problem on the review, but I made it just so you'd be aware of it. Those 2 sets, they don't have the same elements and they don't have the same number of elements, so they're neither. So it's possible for sets to be equal and equivalent, equivalent only, or neither. You can't be equal without being equivalent. If you're equal, you're automatically equivalent. Six is a subset or equal problem. These subsets this means A is contained in B but not equal. This means B is contained in A but not equal. The other 2 subsets, it's contained or equal. So these are contained, but it can't be equal. The other 2 subsets, this one and this one, it's contained or equal. When I look at part A, B is contained in A because every element of B is contained in A. So B is a proper subset of A because it's a subset that's not equal. So that would be a true statement. It's also true that this is true. For this statement to be true, you're either a proper subset or you're equal. So for part A, there's 2 statements that's true because B is contained in A. I don't like my problem B because my problem B is just the same as part A. So I'm going to change it, and hopefully I remember to change it on my video. Let me just do something like this. Let me make B bigger. Make B 1, 2, 3, 4, 5. Just because it's a better problem. Now, in this particular problem, A is contained in B, because for the new B, everything in A is in B. A is a proper subset of B because it's not equal, so that symbol's okay. And anytime a proper subset is okay, that symbol's also okay. Because this symbol, the subset with a line on it, also allows it to be equal. It's either a proper subset or it's equal. So if the proper subset is true, the or equal to part is true as well. Part C, those two sets are equal, so it's okay to say A equal to B. Again, I have a bad symbol here. And anytime you have equal, both the subsets with the equals okay. Saying B is either a subset or equal to A, or saying A is a subset or equal to B are all okay. Sets that are equal, the subset with an equal line under it is also true. So for A, B is a proper subset. And when you have a proper subset, both the subsets are true, the proper one with and without the equal sign. In B, when I changed it to make A a subset of B, and it's a proper subset, so both versions are okay. In C, they're equal. The subsets without the equal signs aren't right. If I put A with a B without this one or that one, that would be wrong, because these two are reserved for them not being equal. The other subsets, it's okay for them to be equal. So that would be a suitable answer for that problem. Hi. I'm talking to myself. So a security guard just popped in to watch me speak to myself. I'm filming a video. And so 7 asks me to list all the subsets of a set. And in order to list all the subsets, it's nice to know how many subsets there are. There's always 2 to the n subsets, where n is the number of elements in a set. In this case, the set has 3 elements. 2 cubed is 2 times 2 times 2, or it's 8. To list all the subsets, there should be 8 subsets. And there's going to be subsets that have 0 elements, and that's the empty set. The empty set is a subset of every set. So one of the subsets I'm writing is the empty set. I can write it as the double open, the set brackets with nothing inside, or I can write a 0 with a line through it. That only stands for 1. I'm just going to do the empty set like that. There's subsets that have 1 element. That would be the set that only contains the number 1, the set that only contains the number 2, or the set that only contains the number 3. So there's 4 different subsets of my 8. There's subsets that have 2 elements, and those are the trickier ones to get, but they're not horrible. You could have the numbers 1 and 3, the numbers 1 and 2, or the numbers 2 and 3. And there's subsets that have 3 elements, and that's the whole set itself. Every set is a subset of itself. It's not a proper subset, but it's a subset. And if I count there, I have 1, 2, 3, 4, 5, 6, 7, 8. So I have all 8 subsets, and that's how many I needed to have. So those are all the subsets of that set A. Eight's not terrible making a Venn diagram. That Venn diagram can be used to answer 9, 10, problem 9, but we don't have to use it to do problem 9. And I'll deal with this right now. So I'm going to make this Venn diagram. I'm supposed to make a Venn diagram, so I'm immediately drawing a rectangle. I only see 2 letters. Well, I see a U, but the U is the whole rectangle. I'm going to make a set and call it A, make a set and call it B. And I fill in Venn diagrams from the dead center. So I find the overlapping numbers. B and A and U all have the numbers 2 and 3. I'm going to put those dead center. Now I'm going to fill in the rest of the A numbers. A still has 1 and 4. A has 2 kind of segments to it, the overlapping section and the non-overlapping section. The 1 and the 4 go in the non-overlapping section. So So I'm crossing them out as I use them so I know not to put them in. I'm going to fill in the rest of B. I've already placed the 2 and the 3 in the overlapping section. The 6 and the 7 that make up the rest of B go in the non-overlapping section. And the only numbers I haven't placed yet are 5 and 8. I've placed all the elements of A and all the elements of B. The 5 and the 8 that I haven't placed just go outside the circle somewhere. There isn't a right nor a wrong place to put them, but they need to be outside the circle. So that's a Venn diagram to represent those particular sets. When I go to do the problems number 9, I'll do the problems with the pictures and with the sets. For me, it's easier to solve a lot of the problems with the pictures, without the pictures. And in order to do the problems without pictures, I need to know each set that could be thrown at me, which are the sets that were given. In this case, 1, 2, 3, and 4 for A, 2, 3, 6, and 7 for B, and I need to know the primes. So what I'm doing now, I'm done with problem 8. This is the end of 8, and I'm preparing to do problem 9. Problem 9 wants me to find some sets that have unions and intersections with sets from this problem 8, and for me, a lot of times it's easier to do a problem without a picture, so I'll do a lot of problem 9s without a picture, than I'll do them with a picture. And in order to do them without a picture, I need to know any set that I might throw at you. If A is the numbers 1 through 4, A prime is the rest of the universe 1 through 8. If B is 2, 3, 6, and 7, the numbers in the universe that aren't in B, 1 isn't in B, but it's in the universe. 4 and 5 are in B, but they're not in the universe, and 8 is in B, but it's not in the universe. B prime is 1, 4, 5, and 8. So when I get ready to do problem 9, I should have those sets, at my fingertips. It'll make it easier to answer the questions if I'm not using the picture. So I'm going to go through and do number 9 without doing the pictures, and then I'll do number 9 via pictures, and you can decide which way you like better. So the first part of number 9 wants me to find A prime. That's simple enough because I've already listed that. A prime is just the sets 5, 6, 7, and 8. And so the answer to number 9, A prime, is 5, 6, 7, and 8. I'll just do the pictures right next to this. You could get the same answer by looking at the picture that we have drawn and understanding what region of the picture A prime represents, and then looking at the numbers that are in that region. Pictorially, A prime represents anything outside the A circle. So it represents any number that I've placed in the Venn diagram as long as it's not in the A circle. And when I look at my Venn diagram, the numbers that aren't in the A circle are that 6 and that 7 and that 5 and that 8. Because A prime implies in the universe but outside, or A complement. Prime and complement we use interchangeably. Are those 4 numbers. They're outside the A circle. To do part B, A intersection B prime, I'm going to replace the A with what it's equal to. I gave you that A is equal to the set that contains 1, 2, 3, and 4. So I'm replacing A with what it's equal to. I'm writing the intersection symbol, and to the right of the intersection symbol, if I'm solving this without using pictures, I'm going to write what B prime is, which is 1, 4, 5, and 8. And when I intersect sets, I write what the sets have in common. And what those sets have in common will be the answer, and they both have 1. They both have 4. So A intersection B prime, the answer to part B that I need to have. When I'm intersecting sets, I get another set. And what those sets intersect or have in common are 1 and 4. If you're into the picture solving, A intersection B prime means inside the A circle and outside the B circle. The A part means inside the A circle. The B prime means outside the B circle. So the region of the graph that I'm trying to locate is inside the A and outside the B. And the region of the graph that's simultaneously inside the A and outside the B is that. When I'm dealing with an and, I have to do, both inside A and outside B. That's that region there. When I look at my graph, the numbers that are in that region that are inside the A circle and, because intersection means and, outside the B are the numbers 1 and 4. For those two problems, A and B, the pictures probably weren't the worst thing. Once we start getting to more complicated problems, for me, solving it with the pictures are hard. The next problem I'm going to do is C, A prime union B prime. I'm going to replace the A prime with what I figured it to be, which is 5, 6, 7, and 8. I'm going to leave the union symbol, and I'm going to replace the B prime with what I figured it to be, which is 1, 4, 5, and 8. So I just took A prime that I figured out before, B prime that I figured out before, replace the A prime with the numbers 5, 6, 7, 8, left the union symbol, replace B prime with 1, 4, 5, and 8. And when I union two sets, I take the entire left set and add to that anything that the right set has that I haven't already included. So the left set, A prime, is 5, 6, 7, and 8. So now I have the entire left set in. And from the right set, I've already included 5 and 8. When you union, you need to add anything that the right set has that the left set doesn't, so I need to add 1 and 4. So A prime union B prime is supposed to be the numbers 1, 4, 5, 6, 7, and 8. Unions are harder to do than intersections via pictures. Union means anything that fits one or the other. And the region of the graph that I want to do is I need to be outside the A or outside the B or outside both. So in this case, A prime means outside the A circle, and then union means or outside the B circle. And pictorially, here's the region that's outside the A circle. And this is the region that's outside the B circle. So it's still outside the A. Basically, what I'm dealing with is everything except this region. This region of the graph is the only region that isn't outside the A or outside the B. It's the only region that's both inside and A simultaneously. So what I'm going to have is everything but any number that's in that region. The numbers that are in that region are 2 and 3. So the numbers that are either outside the A or outside the B or outside both are 1, 4, 5, 6, 7, and 8. Everything but 2 and 3. If you look at my answer, the only thing in the universe my answer is missing is 2 and 3. So for me, doing the problems with the sets is easier than doing the problems with the pictures, because the pictures for me just get to be a little overwhelming sometimes. And sometimes, in order to get the right answer, I kind of cheat. I know the answer ahead of time, then I can draw the picture okay. D wants A union B prime prime. Parentheses are a little bit tougher. I need to do the parentheses first, and then the prime outside the parentheses. So in part D, maybe I won't even do this one with the picture, because I think with the picture it's just too hard. So inside the parentheses, I want A union B prime. A would represent the numbers 1, 2, 3, and 4. The union symbol is the union symbol. B prime are the numbers 1, 4, 5, and 8. And now I'm going to union these. Union, you take the entire left set. The entire left set is the numbers 1, 2, 3, and 4. And I'm going to add to it anything I haven't included in the right set. The right set has 1, 4, 5, and 8. I've already included 1 and 4, so I want to add 5 and 8 to it. So that's the parentheses. The parentheses, A union B prime, turn into the sets 1, 2, 3, 4, 5, and 8. There's one more prime I need to do. I need to define what that set is, and now I need to take the prime of it. The prime of it is every number in the universe that's not in this set. The universe contains the numbers 1, 2, 3, 4, 5, 6, 7, and 8. This set right here, it's missing. The prime is basically what it's missing from the universe. It's missing 6 and 7, and that's what the prime, that's what the answer to this is going to be. So when I did the A union B prime part, I figured out that was the set 1, 2, 3, 4, 5, and 8. When I primed it again, I get everything that's in the universe that this set is missing, which is 6 and 7. And that's just a nuisance to do via graphing. If you want to see it via graphing, come visit me and I'll show you how to do it. But it's messy. The double priming and unions and primings gets hard. For E, to do this, I need to do my parentheses first. And same deal. I think this I probably could do easier on a picture. Maybe I'll show you. The first thing I'm going to do is deal with A intersection B, because I need to do parentheses first. A is the set 1, 2, 3, 4. I'm going to leave the intersection symbol. B is the set 2, 3, 6, and 7. And I certainly like intersections better than unions. Intersections ask me what sets have in common. So my parentheses can be simplified down to one set. I probably really don't need the parentheses when I make the two sets into one. But it's what the sets have in common. Both sets have 2 and 3 in common. So the intersection of A and B is the set 2, 3. So I'm done with the parentheses. I don't need the parentheses anymore. And now I want to union that with B prime. And again, B prime I need to have handy. B prime is 1, 4, 5, and 8. So when I form the union of those two sets, I get my answer. To do a union, you take every element of the left set, which is 2 and 3, and then add anything to the right set that it has that I haven't included. I need to include everything, the 1, 4, 5, and 8. So the union of these two sets always gets bigger. It's the entire left set, and then you add to it anything the right set has that we haven't included, and that's going to be the answer for part E. For those of you that are pictorial, you probably have a better gift than me because I'm not very visually gifted. I'm more visually gifted when there's two sets than when there's three. The first region, A intersection B, is that region, and I want to union that with B prime, which is everything outside of B. So I'm taking into consideration anything in the intersection or anything outside of B. So this is anything that's in A and B, which is the intersection, or outside of B, which is everything except anything in this region. This is a region that's missing. This region has 6 and 7, so it's going to be everything but 6 and 7. If I look at my answer, the only numbers it's missing is 6 and 7, because that's pictorially the region of the graph I'm looking for. I'm looking for everything that's in the intersection or outside B. The only thing I'm not considering is this section right there, and that contains the numbers 6 and 7, and that's why my answer is 1, 2, 3, 4, 5, and 8. So that's the end of number 9. Now I get to 10. Same deal with 10. If I'm comfortable, I can certainly use the pictures to get my answers. If I'm not comfortable, I don't have to use the pictures. And I'm going to blow this up a little bit because it's kind of small. And I'm going to do this non-pictorially. A is anything in the A circle, which is the numbers 1, 3, 5, 7, and 9. B is anything in the B circle, which is 6, 7, 8, 9, and 10. The prime would be the rest of the universe. The universe in this problem contains the numbers 1 through 10. I can see any number between 1 and 10. A prime is any number between 1 and 10 that's not in A, and it's going to be 2, 4, 6, 8, and 10. B prime is any number between 1 and 10 that's not in B, and that's going to be 1, 2, 3, 4, and 5. So I can answer all the questions that are posed in number 10 by just knowing those sets without using the pictures, or I can use the pictures. For me, it's easier not to use the picture. The first one, doing A union B, I take the set A, which is 1, 3, 5, 7, and 9, union that with the set 6, 7, 8, 9, and 10. And when I union two sets, I take the contents of the left set, which in this case is 1, 3, 5, 7, and 9, and I add anything that the right set has that I haven't included. So the right set has both a 6 and an 8 and a 10 that need to be in the union, because the union is anything that's in one set or both sets, or one or both sets. So A union B is the numbers 1, 3, 5, 6, 7, 8, 9, and 10. Pictorially, it's anything that's inside the A circle or inside the B circle. So it's basically anything that's not outside the circle. So pictorially, A is this whole circle, B is that whole circle, and I want to be inside the A circle or inside the B circle, or both. The only thing it's excluding are the numbers 2 and 4. When you look at my list for A union B, the only numbers it's missing are the numbers outside the A circle. So 2, 4 is what's missing. The answer to A union B is 1, 3, 5, 6, 7, 8, 9, 10. This is the answer, whether you get the numbers that belong in this by understanding the region of the picture and then looking for the numbers, or if you just do the symbols. And for me, symbols are easier, so I can continually do the symbols. For part B, I'm asking for A intersection B prime. There's a parentheses, so I'm going to work with the parentheses. For set A, I know that A is the set 1, 3, 5, 7, and 9. Again, I'm just taking that from the list that I constructed at the beginning. So I've made A as 1, 3, 5, 7, and 9. B is 6, 7, 8, 9, 10. And now I'm going to intersect those two sets. When I intersect them, I'm still going to leave the parentheses with the prime so I don't forget to do the prime. Intersecting is what they have in common. And what these have in common is both a 7 and a 9. So A intersection B in general would just be the numbers 7 and 9. But now I want to prime them. And to prime something, that's everything that the universe contains other than those numbers. The universe contains the numbers 1 through 10. So priming this set is going to have every number between 1 and 10, skipping the 7 and the 9. The answer to part B, A intersection B complement or A intersection B prime, are the numbers 1, 2, 3, 4, 5, 6, 8, and 10. Pictorially, if you're pictorially given, this means everything outside the intersection of A and B, or everything that's not in the intersection of A and B. And it represents anything. The intersection is the very middle. Priming the intersection means everything outside of that. And when I look at my picture, the only thing in the intersection is 7 and 9. The only thing this is excluding is 7 and 9. That's the only thing missing from my set. Part C has a parentheses and a union. It makes it hard. I'm going to do the parentheses first. The first thing I see is A prime. A prime is the set that contains 2, 4, 6, 8, and 10. I want to intersect that with B, which is the set 6, 7, 8, 9, and 10. And then I'll worry about the union A. So intersecting two sets is what they have in common. Again, I just picked out the A prime that I figured out at first, the B that was given to me. Intersecting, both of these sets have 6, 8, and 10. So the parentheses simplifies to be the set that contains 6, 8, and 10. I don't need the parentheses anymore because there's no prime to do here. Now I want to union that with A, and A is the set 1, 3, 5, 7, and 9. And when I union two sets, I get a bigger set that contains the entire left set, and then I need to add anything that the right set has that I haven't included. So my answer to this is got to be gotten when I union these two sets. I'm going to take the entire right set, which is 6, 8, and 10, and then I'm going to add anything that the right set has that I haven't included, and that's the whole right set. So I'm going to add 1, 3, 5, 7, and 9. So the answer to part C is 1, 3, 5, 6, 7, 8, 9, and 10. Pictorially, this is a mess. The first parentheses means inside A and means outside A and inside B. And that by itself represents this region. That's the region that's outside of A and inside of B. And this says or inside of A, and I have to add anything that's inside of A, so I'm adding that. And that's the region pictorially that I need to this depicts, and that represents everything but those numbers 2 and 4. That's the only number that's missing from the picture. I look at my list, and it's only missing the numbers 2 and 4. So pictorially, this is the picture that that graph that figure represents. $11, lots of sets here, and the funky symbol that I don't know how to get rid of. When I look at my questions for number 11, I was kind, and I don't see an A prime, a B prime, or a C prime. So I'm just going to write down the sets A, B, and C. But I could write, it wouldn't be wrong to write down A prime, B prime, and C prime. I'm going to cross those out. That symbol shouldn't really be there. A is anything in the A circle. The A circle contains the even numbers between 4 and 18. A is 4, 6, 8, 10, 12, 14, 16, and 18. B is anything inside the B circle. And the B circle contains 6, 9, 12, 15, and 18. And C is anything inside the C circle, which is the numbers 5, 6, 10, and 15. I can do this part A without any primes, so I'm going to do that. I'm going to do A intersection, and then the parentheses wants a B union C. For B, I'm going to write 6, 9, 12, 15, and 18. For C, I'm going to write 5, 6, 10, and 15. And when I union those two sets, I take the entire left set, which is 6, 9, 12, 15, and 18. So I've taken the entire left set, and I'm going to add anything from the right set that I haven't already added. I already had the 5 and the 6 and the 15, so I need to add the 5 and the 10. So the union of those two sets gives me the set 5, 6, 9, 10, 12, 15, and 18. Now I'm going to do the intersection. A is the set that contains 4, 6, 8, 10, 12, 14, 16, and 18. I'm intersecting that with the set that has 5, 6, 9, 10, 12, 15, and 18. And when I intersect sets, I look to see what they have in common. I see a 6 here and a 6 there, a 10 here and a 10 there, an 18 here and an 18 there, oh, and a 12 and a 12. I almost missed that. So it's what they have in common. Those two sets, what they have in common, will give me the answer to this. It's the number 6, 8, 10, 12, and 18. This is the kind of thing that would be good to do in front of a class because it's real easy to miss a number. If I'm pictorially to get this answer, the region that's represented with B union C is anything that's in the B or the C circle. So the beginning picture, B union C, is this, and I want to intersect that with A, and when I intersect that with A, I get this region and this region. So these are the regions that the picture is, because I want B union C intersected with A. B union C is either the B or the A circle. Intersected with A is this. And really, now I'm concerned that my answer is not right. So I'm going to go back and reevaluate because I think it should be 6, 10, 12, and 18. This 8, this 8 didn't belong there. Look at that. I wrote 6, 10, 12, and 18. This 8 isn't in both sets. It doesn't belong in my answer. What belongs in my answer is the 6, the 10, the 12, and the 18 that are in both regions. This is because the region that this was describing was these regions, and the 8's not in that region. So hopefully you caught that before I caught myself. Because I can do the problems both ways, I found my mistake pretty quickly. But it really takes a special gift to be able to understand pictorially what the regions are representing, and that's not something that I expect you to be good at. It takes a long time to get competent with that. So B wants me to do a prime, but it's a prime of A union C. So the universe for this problem, the universe contains the numbers from 4 to 19 as near as I can tell. To do A union C, A we figured out, or I figured out, was 4, 6, 8, 10, 12, 14, 16, and 18. C is 5, 6, 10, and 15. So I'm going to union these two sets, and when I union these two sets, I'm basically going to push them together. I'm going to take the 5 from this set and get it in that set. The 6 is already there, the 10's already there, and I'm going to get the 15 in there. So when I union these two sets, I get 4, 5, 6, 8, 10, 12, 14, 15, 16, and 18. And now I want to do the prime. The prime of a set is everything that the universe contains that's not in the set. The universe is the numbers from 4 through 19. The prime of this set is going to be anything in the universe other than, any number between 4 and 19 that's not in the set. So this set is missing 7, it's missing 9, it's missing 11, it's missing 13, it's missing 17, and it's missing 19. This one's not that hard to do pictorially. The picture of this means anything outside of the A and the C, outside the union of A and C. The union of A and C would be the A. This is the A circle. This is the C circle. And I want to do the complement of that. So the complement of the union is everything that's not in that region. So it's going to be this region here. That's outside of A and it's outside of C. And this region out here. These regions in red are the numbers that I'm looking for. And those numbers, I see the number 9 there, and the numbers 7, 11, 13, 17, and 19. So I see 7, 9, 11, 13, 17, and 19. My answer is correct. This means anything that's outside of the union of A and C, so that means anything I haven't read there. The last one's actually very easy to do pictorially. A union B union C means anything in any of the 3 circles, basically anything that's not outside a circle. But I'll do this the long way because it's easier for me. So A union B union C, I can just work from left to right and first do A union B, A is the evens between 4 and 18. B is the 6, 9, 12, 15, and 18. And then I'll worry about the union C. So what I'm going to do is add what's missing that this set has. I'm going to put the 9 in, and I'm going to put the 15 in. I already have the 6 to 12 and the 18. So the A union B comes out to be 4, 6, 8, 9, 10, 12, 14, 15, 16, and 18. I'm going to union that with C, and C is 5, 6, 10, and 15. And by unioning, I'm going to add into this set, I'm going to add the 5. I already have the 6, I already have the 10, and I already have the 15, so that's all I'm going to add. So A union B union C is going to be 4, 5, 6, 8, 9, 10, 12, 14, 15, 16, and 18. That's the answer. Pictorially, it's anything in any one of the, in the A, the B, or the C circle. Pictorially, it represents any number that's in any circle. It's just excluding the numbers that's outside the circle. It's going to be missing 7, 11, 13, 17, and 19. You'll see I'm missing 7, I'm missing 11, I'm missing 13, I'm missing 17, I'm missing 19. When I, do these problems, when I'm new to doing these problems, I probably specifically only do the symbol way rather than doing the picture way. But if you're really comfortable and you're gifted visually, then the picture way is a great way to do these problems. It's just for me, it's hard to do the pictures because it varies from problem to problem. You have to do a lot of them to get comfortable with the pictures. So all I have left is the problems that are the picture, the Venn diagram problems. The first Venn diagram problem is 12, and it talks about 100 people that like chicken and pork. 28 that like both are the easy numbers to get. So when I go to create a Venn diagram for these 100 people, some liked the chicken burrito, some liked the pork burrito, and 28 liked both. In the dead center of the diagram, it's going to be 28 people that liked both. The 50 that liked chicken, some of them liked only chicken, some of them liked both. So this problem says 50 liked chicken, some liked both, very specifically, 28 liked both, and some only liked the chicken. So that 50 people gets broken down between 28 that liked both and whatever 50 minus 28 is, and I'm going to pull my calculator out as to not make a horrible math error. Not that I shouldn't be able to do that in my head. There's 22 people that liked only chicken. So when I go to fill in my Venn diagram, this region right there, that separates the 50 that liked chicken into the 28 that liked both and the 22 that liked only the chicken. The 40 that liked pork gets separated into some that like both and some that like only the pork. And again, I know how many liked both. I was told that 28 liked both. So if I subtract the 28 that liked both from the 40 that liked pork, I get the 12 that only liked pork. So the rest of the pork gives me 12. This survey is supposed to make 100 people up. If I add up the numbers that I have in here, I have 22 plus 28 plus 12. I've only taken into consideration 62 people. The difference between the 62 people and the 100 give me the ones that didn't like either, and that's 38. So again, the middle number for these Venn diagrams is always given. The outside numbers I subtracted. So I constructed a Venn diagram. How many liked only pork? That's this region here, this 12. How many didn't like either? That's this 38 here. Once you get the Venn diagrams, the questions usually aren't that hard to understand. Venn diagrams with 2 circles are a lot easier with Venn diagrams with 1 circle because only 2 subtractions to do with 3 circles. When you get 3 circles, you're going to have 6 subtractions to do, so it's 3 times as hard, maybe 7 subtractions, I guess. So that's 12. And then lastly, the last problem on the review talks about students taking math, English, and chemistry. When I go to make a picture, I'm going to make a circle for math, a circle for chemistry, and a circle for English. And I always fill these up dead center. The 11 that are taking all 3 belong in the dead center of this circle. And the rest of the way I'm going to subtract. Now I'm going to go to the double areas. So those that are taking math and English, to figure out the rest of the overlap between the math and the English, I have to subtract the 11 that are taking all 3 that are included in there. 40 minus 11 is 29, so there's 29 students taking only math and English, and that's this region right here between the math and the English circle. The 19 that are taking chemistry and English, 11 of them are taking all 3. 19 minus 11 is 8. In the region between the chemistry and the English, there's 8. So this 11 and that 8 give me the 19 students that are taking chemistry and English. 8 are taking just the 2, 11 are taking the 3. And the last subtraction with the 2s, I'm going to go 24 minus the 11. The 24 that are taking chemistry and math minus the 11 that are taking all 3 is going to give me 13 students that are taking math and chemistry and not taking English. Now I'm going to go to the singles and subtract whatever's in the circle. For the chemistry, I'm going to take 40 and minus the numbers that are in the chemistry circle. In the chemistry circle, there's a 13, an 11, and an 8. I'm going to add the 13, the 11, and the 8 that are in the chemistry circle. There's 32 students already considered in the chemistry circle. Of the 40 students that are taking chemistry, 32 are taking one or two more classes, and there's going to be 8 students that are only taking chemistry. So when I do these Venn diagrams, I'm subtracting all the time. Every single number other than the dead center, I'm subtracting. And I kind of work my way outside in. For the English circle, I take the 62 that are taking English and subtract these numbers. And this number is a 29. Not that it really looks like a 29, but this 40 minus 11 was a 29. So I'm going to take the 29, the 11, and 8, the numbers in the English circle, and add them up. So I go 29 plus 11 plus 8. That gives me 48. I'm going to take the 62 students that are taking English, subtract the 48 that are taking more than English, and I get 14 students that are taking English only. Do the same with the math. I go to the math circle that has a 29, 11, and a 13 in it. I get 53 students that are taking math with some other class. I subtract the 60 math students minus the 53, and I get 7 that are taking math only. This survey incorporated 100 people. I'm going to add up all the numbers in the circles to get the number of people that are taking at least one of the classes. So I'm going to go 7 plus 29 plus 11 plus 13 plus 14 plus 8 plus 8, and I get 90 students that are taking at least one of the classes. There's 100 students total, so I'm going to go 100 minus 90 and get 10 students that aren't taking any of the 3 classes. So once you get the Venn diagram filled up, I hopefully don't make the questions so complicated that you can't answer the questions. The first question, how many are only taking chemistry? That's these 8 here, assuming that I didn't make any horrible math errors. For part C, how many aren't taking any of the 3 classes? It's those 10 there. And for part D, how many are taking exactly 2 of the 3 classes? That's these regions. The 13 here that are taking math and chem, the 29 that are taking math and English, and the 8 that are taking English and chem. For that part C, I'm going to add up the 13, the 29, and the 8, and I get 50 students. So if you're watching the video this weekend and you feel like I made a mistake, I'm sitting in here by myself doing these, and there's a chance that I made a mistake, send me an email. I'll look at my problem again. If it's a mistake, I'll make a little note on my webpage. Hey, I did this problem and the video has a mistake. Hopefully there's not a single mistake on my video, but there's definitely the chance. So if you felt like I made a mistake, there's a chance, and I'll look at it, tell me, and I'll try to fix it if there is. If you're not understanding this, then before we get to the test, you should make a big effort to come visit me, and I'll try to make it so that you understand the material well enough to do well on the test. Okay, so hopefully this helps somebody out, and you all do well on the test.